Hi everyone. In this video, we are going to talk about Node.js event loop. We all know that Node.js runtime is single-threaded in nature. So programming languages like Java and .NET, they have the capability to do multiple things at the same time, right? But Node.js cannot do multiple things at the same time. But Node.js can still achieve the concurrency using this event loop mechanism. And that's what we are going to focus on this video. So let's begin. Node.js runtime has multiple components which we need to understand before we try to understand the event loop. So the first one is call stack. So call stack is a stack data structure which keeps track of all the functions that gets executed by the Node.js runtime. And so it follows the principle of stack, first in, last out. Right? So whenever a function gets executed by the Node.js runtime, the function gets pushed into the call stack. And once the function execution is completed, it will be removed from the call stack. And the concept of call stack is not something that is very unique to Node.js. It's a common concept across all the programming languages. Now, the next thing, we have a task queue. So the task queue keeps track of all the asynchronous functionalities that needs to be executed by the Node.js runtime. Actually, we will talk about the task queue in detail, but just keep in mind that task queue follows the principle of queue, first in, first out. And we have this operating system. So Node.js efficiently relies on the operating system and it delegates most of the tasks to the operating system kernel, and that makes the runtime much faster. So there are few C++ libraries running under the hood, which enables the communication between the Node.js runtime and the operating system. Now let's try to understand how Node.js execute an example program internally. Okay, so we have a simple program here. It is a very simple program which has one function called say hello, and that does nothing but just prints a word hello to the output terminal. Now when the Node.js start executing this program, it pushes the functions into the call stack and then executes it one by one. Now first, when you start the execution, it pushes the main function into the call stack. And but you can see there is no main function explicitly declared in the program, right? So in programming languages like C# or Java, you have to explicitly declare the main function and then write everything inside it. And that becomes the single entry point for your application. But in case of Node.js, you don't have to explicitly declare the main function. The JavaScript will take care of that for you. So it creates a main function and wraps everything into that function. So when you start the execution, it puts the main function into the call stack. Now it goes the instructions one by one. Now it reaches this particular line. We are declaring the function say hello. It's not actually executing anything. It just registers the function and then move on. So it comes to this particular point where we are actually invoking the function say hello. Now at this point of time, the say hello function will move into the call stack. Now it gets moved into the call stack, and the execution now get into the say hello function. Now inside the say hello function, we have one more function which is console.log. So now this function needs to be moved into the call stack. Now the console.log function will start its execution. It prints the word hello to the output terminal, and once that execution is completed, as I already told you, the functions will be removed from the call stack. So now once the console.log function completes the execution, it will be removed from the call stack. And you can see here, there are no other instructions available in the say hello functions, which means the say hello function is also completed the execution. So that function now will be removed from the call stack. And you can see here, the say hello, invoking the say hello is the last line here, and there are no other instructions, which means the main function is also completed the execution. So that function will also removed from the call stack. Now at this point of time, you can consider the program completes the execution, right? And this is a good example for synchronous execution. And it's a very simple program. We are not doing a lot of things, and it executes very faster. And even the console.log function would take a couple of microseconds to execute, right? So this is a very simple synchronous way of executing a program. Now imagine you have to do some long running process inside this program. Say you want to write some huge amount of data into the file system. Right before you print the word hello to the terminal, you want to write some huge amount of data into the file system. Let's say how the Node.js execute that kind of use cases. Now let's try to invoke the function that will write the data into the file system. So let's call a function fs dot write sync and then pass the data. So this is a function that will actually write the data into the file system. Technically, this may not be the actual API to write the data, but you can refer the Node.js documentation for the exact syntax. But just for the demonstration purpose, I just make it readable, that's it. So let's try to rerun the same scenario, how the Node.js internally execute this program, okay? So similarly, first it moves the main function into the call stack. And then it moves the say hello function into the call stack. And then it comes to this particular point where we are invoking the write sync function. So that function will be moved into the call stack. Now at this point, the write sync function actually talks to the operating system, and then it supplies the data to the operating system. Then it will try to write the data into the file system. Now since we are calling the synchronous function here, since we are making it synchronous, the Node.js runtime will wait for the response from the operating system, and it will not move on to the next line until it gets the response from the OS. And that's the huge problem. Because since the Node.js runtime is waiting for the response, you cannot do any other activities in the application. So your application is technically blocked, right? In other programming languages like the Java or C#, we have this capability of multi-threading. So whenever you want to do this kind of long-running process, you simply create another thread and delegate this functionality into that thread. By doing that, you are actually keeping your main thread free. But in this case, Node.js does not have the capability to do multi-threading, so you have to call this function in the same main thread. Because by doing that, we actually blocked the main thread, right? The main thread is the only thing that is performing all the primary operations. Now, since that is blocked, it cannot do anything else. Now this is where event loop comes into picture. Now let's see how do we solve this problem using the event loop. Now let's go ahead and convert this blocking code into non-blocking code. Now we just have to change this function from synchronous into asynchronous. So instead of calling the sync version of the write function, we are going to call the asynchronous version. Usually when Node.js exposes libraries, when Node.js exposes the core functions, it actually exposes two versions, the synchronous and the asynchronous version. So we are going to call the asynchronous version of writing the data into the file system. Now when the asynchronous function gets moved into the call stack, again the same thing happens. It talks to the operating system, it supplies the data to the operating system, and the OS will write the data into the file system. But one main difference in this case is the Node.js runtime will not wait for the response from the operating system. Instead, it will just call the function and then it will move on. So this is why whenever you call an asynchronous function, it is important to supply a callback as well. So when you call a write async function, in addition to passing the data, you also have to pass a callback. Which means once the function complete the execution, the callback should be executed. That's the expectation. Now the Node.js will talk to the operating system. It gives the data to the OS, and it also supplies the callback to the OS. Now the OS will start writing the data to the file system, and once that operation is completed, it will push the callback to the task queue. So once the data is written to the file system, the OS will push the callback to the task queue. When I say OS, the C++ libraries that enables the communication between the runtime and the OS, so that will help pushing the callback into the task queue. In the previous example, when we execute a synchronous version of the file writing operation, it actually talks to the operating system and waits for its response, right? And that's why it blocks the entire main thread, and that's a problem. Now, when we use the asynchronous version of this function, and when the execution comes to this point, it actually pushes that function into the call stack. And then similarly, it talks to the operating system and it tells the operating system, hey, this is the data that you have to write into the file system. And let me know once that operation is done. Just notify me once you've done writing the data into the file system. I'm not going to wait for you to respond. I'm going to move ahead and do the other activities. You just let me know once it is done. So that's what Node.js runtime is going to tell the operating system. And then it will move on. So once that communication is done, we can consider this particular function is completed. So it will be removed from the call stack. And then we have the next function, console.log, that will be moved into the call stack. And that will print the word hello to the terminal, and then it's complete the execution. So it will be removed from the call stack here. And then there are no more instructions available in the say hello function. So the say hello function is also completed the execution. And that's it. There are no more instructions in the program itself. So the main function is also completed the execution. So the main function is removed from the call stack. In the previous example, when the call stack goes empty, we consider the program completes the execution. But in this case, it's going to be a little bit different. So the call stack is empty, but still we have a callback waiting in the task queue to be executed, right? So this is where the event loop kicks in. Event loop, as the name implies, it is actually a loop which continuously monitoring the call stack. And whenever the call stack goes empty, it will check the task queue. If there are any functions available in the task queue, it will take the function and it will put that into the call stack. So we have this callback waiting in the task queue to be invoked. So that callback will now go to the call stack, and now it will start executing. And this callback might have a lot of other functionalities to be executed. All those functions will also get into the call stack, and it will start executing one by one. And if there are any asynchronous functions available in the callback, again the similar thing will happen. It will talk to the operating system, delegate the functionality to the operating system, and then once that job is done, OS will push the callback into the task queue. And when the next iteration of the event loop kicks in, when the call stack goes empty, and if there are any callback available in the task queue, the event loop will move that function to the call stack, and the same loop continues again and again. This is how Node.js actually achieves the concurrency using the event loop mechanism. Now, till now, we were talking about the event loop mechanism from the perspective of Node.js, but this is actually same in the browser as well. Browser is also using the JavaScript as the primary language to build any front-end applications, right? So you want to achieve concurrency in the browser-based applications as well. So this is the same mechanism. This is the same event loop mechanism that will run in the browser as well. In this case, JavaScript make use of the operating system to do the heavy lifting. But in case of browser, the browser actually takes care of the heavy lifting. So in this video, we talks about the Node.js internal working, how the Node.js runtime actually execute your program, and then we saw how event loop actually solves the problem of concurrency. How do you convert your blocking code into non-blocking code? Whenever you write JavaScript code, you need to make sure you don't write any blocking code in your example, so in your code. Because since JavaScript is a single-threaded in nature, any blocking code that you write in your program will block the entire application. So make sure, try to use asynchronous calls wherever it is possible and delegate defer the functionality as much as possible. I hope this video is really useful to you. Thanks a lot for watching.